The question we are solving now belongs to test series 4. It is of network theory subject. In specific, it belongs to network solution methodology. Please note that this is a common data question. As per the question, there is a DC network given as shown, which contains a parallel combination of two 2 ohm resistors, and there is another 2 ohm resistor connected as shown, and there is similarly a parallel combination of two 8 ohm resistors which is connected to a 4 ohm resistor as shown. Please note that the common point of these two is connected by a R ohm resistor and the current through the same is I. And the complete DC network shown here is supplied by a 10 volts voltage source. We need to find the maximum possible value of power that can be dissipated in R in watts. We know that for maximum power dissipation, R should be equal to RTH. So for finding the same, we can draw the equivalent circuit as shown, for which this two 2 ohm resistor can be parallel connection of two 2 ohm resistor can be replaced by a 1 ohm resistor. Similarly, parallel connection of two 8 ohm resistors can be replaced by 4 ohms. And for RTH, as the circuit doesn't contain dependent sources, RTH is equal to the resistance viewed from the terminals of R. So R is kept open, and for finding the maximum power dissipation, for finding the resistor value for maximum power dissipation, hence RTH, hence RAB, we know that RTH is equal to RAB, and for finding RAB, we need to replace the sources by their corresponding internal resistances. So from this, the Thevenin's resistance RTH is equal to RAB is equal to 2 by 3 plus 2, that is the resistance seen from the terminals A and B, which upon simplification becomes 8 by 3 ohms. So from this we see that for maximum power dissipation, the value of the resistor R is 8 by 3 ohms. Similarly, for finding the maximum power dissipation, we need to find the Thevenin's voltage, and the Thevenin's voltage is equal to the open circuit voltage between terminals A and B. For finding the same, now let us connect the 10 volts voltage source. So from this we see that the Thevenin's voltage can be written as 10 into 2 divided by 3 minus 10 divided by 2. So this upon simplification becomes 5 by 3 volts. This is by voltage divider rule. The drop across the 2 ohm resistor is 20 by 3 volts, and the drop across the 4 ohm resistor is 5 volts. From this we see that the Thevenin's voltage is 5 by 3 volts. So we know that for maximum power dissipation, RL should be R should be equal to RTH, which is equal to RAB in our case because the circuit contains only independent sources. So and the corresponding maximum power dissipated can be given as VTH square divided by 4 RTH. Upon substitution, this becomes 25 by 9 divided by 4 into 8 by 3. This upon simplification becomes 25 by 96 watts. From this we see that the maximum power dissipated in R is equal to 25 by 96 watts, which is found out for R is equal to RTH. From this we see that the correct option representing the maximum power dissipated in R is C.